Hello friends, in this sections we are going to learn CPU core sections in older motherboard laptops, how the CPU core voltage is generate and what to do if the CPU core voltage will not generate. What are the test points are there, everything we are going to learn in this sessions. Plus we'll learn the schematic diagrams of the CPU core section, their test points and all. So let's start. So the CPU core voltage is the final voltage for the CPU. All the previous voltage are generated like 3.3, then 5, then 1.5, then 1.8, then 1.05. All the different voltages are required to the different sections of the entire motherboard. And when the all voltage are stable, then the CPU core voltage will be turned on. Okay, so that is a basic criteria to generate the CPU core. And then this VRM chips is here. This VRM chips, the full form of the VRM is called the voltage regulator module, and this VRM chips generate the CPU core voltage. In CPUs require basically a current, and that current is somewhere around 30 to 30 ampere somewhere. And in generation 1 and 2 and 3, the CPUs require CPU core as well as the graphics core voltages. So there are the two core voltages. One is called the CPU core and another is called the graphics core. And when we are going to check this voltages, then there will be somewhere around 1 volt we find across this capacitor. These are the capacitors. Okay, so we'll start. And now this one is called the VRM chip, CPU core chips, and this chip is approximately 40 to 48 pins. It's depend model to model. Normally the ISL make the CPU core chips, and the CPU core chips require normally a 5 volt, that is a 0 voltage, that is 5 volt. And some CPU core chips require VIN voltage also, and VIN voltage here is supposed to be a 18 or 19 volts, depend model to model. Okay, so some models require 2 voltages and some models require only the 5 voltages, that is thing. And then here is a one pin, and this pin is called the VSense. VSense is a pin to detect the CPU, whether CPU is there or not. If the CPU is there, then this chip is connected to the ground. That means the 0 will, when you going to check this pin by multimeter, then you will get a 0 ohm resistance across this pins. So this pin is called the vsense. That means this pins detect whether CPU is there or not. If it won't detect the CPU there, then this CPU core section or this VRM chips not going to turn on CPU core voltage. That is one thing. The another thing is CPU, this VRM chips detect the temperature also around this CPU core area. And for that, the designer used this NTC. The NTC means the negative temperature coefficient, is one kind of thermistor where he detect the temperature around the CPU sections. If the temperature is normal, then this NTC inform this the VRM chip that temperature is normal, and in that case the CPU core chips generate this VROT signal. The VROT signal is supposed to 1 volt to 1 3 volt. If the 1 volt is here output or 3 volt is here as output, that means the VROT signal is normal. That means the CPU core temperature is a normal. And if this VROT signal is a 0 volt, then these chips detect the abnormal temperature in the CPU area, and in that case this VRM chips is not going to turn on this core voltages. So before, if in your laptops the CPU core voltage is not generating, then these are the test point you have to check. So what you have to check first, you have to check VROT signal is supposed to 1 volt. Then you have to check the resistance across this pin VSense. VSense is a pin to detect whether the CPU is there or not. Okay, so this thing. And the third thing that you have to check, that is a VCC supply, that is a 5 volt. Exact 5 volt should be there, not 4.7, something like that. If here the voltage is 4.7, then also this chip won't turn on. Okay, so you have to make sure here the 5 volts should be there to turn on the chips. And these are the buck converter MOSFET. And here the pairs are used, like here the pair. And this CPU, I already told that the CPUs require a current, and that current is supposed to be a 30 ampere. So one buck converter cannot generate that much of current, so that is why the multiple buck converters are used to generate the CPU current. And one buck converter normally generate approximately 10 to 15 ampere current. So here are the two buck converters are used, and both buck converters are connected to the parallel, because in the parallel circuit the current is increased, not the voltages. Okay, and CPU require another core voltage, and that is called the graphics core voltage. And the graphics core voltage also is require somewhere around 10 to 15 ampere. Okay, so but when we are going when this voltage is turned on, at that time we can get here approximately 1 volt. Okay, so these are the criteria. These are the switching MOSFET. High current switching MOSFETs are there, connected in a cascade circuit, connected in the parallel to each other. These are the pairs. Okay, and now this VRM chips is going to turn on. And to turn on to this VRM chips, these chips already got the supply, that is a 5 volt. And now these chips require one command, and that command is called the VR on command. And this command normally given by the SIO, and that's supposed to be 1 volt to 3 volt. In it's depend to model. Is in Compal and Quanta motherboards, this command is given by the SIO. In Wistron motherboard, this command is generated by cascading. That means by this circuitry turn on one after another. Okay, so here in this concept we are going to learn. So here is the SIO generate this signal, that is called the VR on. That is the enable signal to this VRM chips. And this voltage is supposed to be 1 to 3 volt, from 1 volt to 3 volt. Okay, so here the 1 volt to 3 volt is generate, that is the enable signal to the VRM chips. That means this SIO saying to this VRM chips to turn on his department. Now after receiving this signal, and if everything is okay, like if the is got the 5 volt, is got the V sense, and if the temperature is normal, then this VRM chips start functioning and triggering these MOSFETs. These MOSFETs are there: upper gate and lower gate, upper gate and lower gate, upper gate and lower gate. It's started switching this MOSFET on their gates. And once they started switching, that's 18 volts started chopping, cutting, and the pulsating AC voltage will be generated here. And then 1 volt and 1 volt and 1 volt output will be generated at this point, this point, and this point. And this CPU core voltage joined together from this buck converter, and from this buck converter, and going to the CPU. And the graphics core voltage also is going to the graphics sections of the CPU. So in step number 5, the CPU core and the graphics core voltage will be generated. And I already told you that here is the current is considered, not the voltage. But when we are going to check on the multimeter, we'll find there approximately zero point 0.9 to 1 volt will be there across this point. Okay, and then once the CPU got this power, then CPU started communicating with this VRM chips, and this signal is called the SVID signal. Now what is the SVID signal? SVID signal is a communication protocol from the CPU to the VRM chips. Here the CPU says to the VRM chips that how much current is requirement. So what is this requirement? And this is a two-way communications protocol between the CPU and to VRM chip, like this. These are the pulses. You can check this pulses by using a multimeter. There will be the clock and the data. These are the two line VID signal. And from that, if this VID signals are coming, from that you can come to know whether CPU is responding or not. So that is a basic criteria to testing the CPU also. For that you need a oscilloscope or the analyzer. After VRM chips got the signal and he changed the whatever the requirement voltage generate for the CPU, which is given to this voltage to the CPU started functioning, and when the voltage gets stable at that time, this VRM chips omit one signal, and that signal is called the VRM power good. Here is a VRM power good means the CPU core voltage is stable and CPU core voltage is working fine. So that step number 5, the CPU core section generate this power good signal, that is called the VRM power good, and sometimes it's called the IMVP power good, and sometimes it's called V gate also. So these are the three names as given to this power good signal. Okay, so this is a concept for the CPU. So now friend, if your core voltage is not generating in your laptop, you have to follow these simple steps, simple numbers. Okay, and if this all the signal, you have to check one after another. Okay, so now we'll go to the schematic diagram and we'll learn this is a test point and how to read the schematic diagram for the CPU core sections. So friends, here I open a schematic diagram of a Compal laptop's motherboards, and we are on this VRM section of the CPU core sections, and I'll just zoom. First we'll see this VRM chips. So here is my VRM chips. This is my VRM chips, and the location for the VRM chip is a PU700, and the chip number is ISL95833. So this is the number of the VRM chips, and this is a TQFM 32 pin chips, and this chips, first we'll see where the power goes. So for that we have to find a VCC, VDD or VIN pin. So we'll see where are those pin. Okay, here CC, here is a pin number 21 and 22. Pin number 22, 21 and 22 is a supply pin, VDD and VCCP, and here we should get a 5 volt. You can see here the plus 5ES, that means the 5 volt suspend voltage is coming to the pin number 21 and 22. So dear friends, if the CPU core voltage is not coming in your laptop, then first thing that you have to check this two pin, the 5 volt. Okay, and another thing that you have to check, that is a VROT. Here is a VROT output pin. So pin number 6 is a VROT pin. So this is a VROT pin. It's going to the page number 40. This is the output signal coming out from this VRM chips at pin number 6. You should get approximately 1 volt here, and if this 1 volt is not coming here, then you have to go to the pin number 7. This is mention the NTC pin. Here is a thermistor. Here is a thermistor. This is a NTC thermistor. NTC stand for negative temperature coefficient thermistor, and the value of this thermistor is a 470 kilo ohms on the normal temperature, and one resistor is connected to the parallel to the thermistor, that the value of that resistor is a 27.4 kilo ohm, and this thermistor and this resistors are connected to the parallel. That's create one resistor that you have to calculate it somewhere around 20 kilo ohms, somewhere I hope so, somewhere around 20 kilo ohms will be there. And one more resistor is here, is connected to the series of the circuit, and the value of this resistor is 3.83 kilo ohms. Now this entire circuitry is a measure the temperature of the CPU core area. Now if the CPU core voltage is CPU, if the CPU temperature is increases at that time, this value of this resistor is going down and down and down and down. It's depend on the temperature. Now if the temperature is rises, the value of that resistor is decreases, and then here is at pin number 6 the 0 volt will be generated. Now in your laptop, if the voltage is coming here a 0, that means that point you have to check all this resistor, you have to check this resistor, you have to check this resistor, and then you have to check the value of this thermistor. Okay, so in this way you can check. Now if your temperature is normal, and then your VR hot signal is a 1 volt, then everything is normal. But still, if your core voltage is not generated, then you have to go to the VSense pin. Now if everything is okay, then this chip will get a enable signal. This is called the VR on signal. This signal is coming from page number 40. The name of the signal is VR on, passing through this resistor. This is 0 ohm resistors, and is going to the pin number 2. This is called the VR on. Once this chips get this VR on signal, started triggering this MOSFET. These are the MOSFETs are here, upper gates and lower gates, and here also MOSFETs are there that started switching and generate the CPU core voltage. Here is called the VCC core voltage, that is supposed to be a 33 amperes. Okay, it's called a VCC voltage. And then here will the graphics core voltage. Okay, so the graphics core and the CPU core voltage will be generated across this capacitor, output of the capacitor. And then here the VRM chips generate the power good signal, and that power good signal is called the VRM power good. We'll see which are this pin. You can see here pin number 15. It's called the P good. Now this P good is output pin, and see this P good name is called the V gate. Sometimes it's called the V gate, sometimes in some models called the VRM power good or called the CPU power good. So this is the output signal is going to the page number 15 and 6, saying the core voltage is stable. And before that, the CPU communicate this VRM chips via this 2 pin. This call this call this called the SVID signal, and here are the 3 SVID signal: clock, data, and alert. Okay, so these are the signal. You can get here the pulses when the CPU communicating with this VRM chips. Okay, and if the pulses is not coming here, that means the CPU is not responding. Here's the graphics core voltage is also, there's the graphics power good also output, and here for the separate NTC for the graphics sections also there. Okay, so in this way the CPU core and the graphics core voltage will be generated. So thank you very much for watching this video.